Thanks for coming today, guys. Your quick wins, leveraging GCP for rapid prototypes. As mentioned, my name is Patrick. I'm a technical business analyst here at Augusto on the advanced services team. By my side here, got Ray Pitmon. He's our solution architect, also with the advanced services team. If you're not familiar with Augusto, we're a tier 1 GCP partner. We are located in the Minneapolis, Minnesota. That's where our HQ is. If you have any questions about Augusto or you just want to learn more, feel free to stop by our booth. 1321, it's got the big red A above it, so pretty easy to spot. Moving along, so today, what are we going to talk about? We're going to talk a little bit about some of our customer stories. What did they do? What issues did they have? And how did we help them solve those issues? After that, we're going to review some of the architecture trends. There's really two different use cases, two different types of projects that we're going to review. So we're going to look at the architecture trends amongst those types of projects. I'm going to hand it off to Ray then. He's going to review some of the common services that we're using on these rapid prototypes. Before I move on here, though, I just want to get a quick idea of where everyone in the audience is at with GCP. So I guess first question, who knows what GCP stands for? Okay, good. All right, we're off to a good start. So who's using GCP in production right now? Or you're well on your way? Okay, cool, good. How about if you're evaluating GCP, maybe you're on your way, but it's still kind of new? Couple hands? All right, cool. Good, got a mixed people here, so that's good. Last question. So some of you might know 12 animals of the lunar calendar. I don't know if anyone's familiar with that here. How many of you know what year 2019 is? What animal it represents? The year of the pig. So once we learned that, coming from Minnesota, we couldn't pass up the opportunity to talk about one of our favorite clients and their internet-connected pigs, a project that we more affectionately refer to as the Internet of Swine. So you might be wondering, why would someone want to connect their pigs to the internet? It seems a little bit weird. We thought it was a little bit strange when we first were approached with this opportunity, but see, our client is an egg tech company, and they saw an opportunity to help farms improve their efficiency and increase revenue. They knew that they spend a lot of time monitoring the health of pigs, right, for reproductive reasons, and they're also very prone to get sick. So if they could track their activity and build a predictive data model around it, they could help the farm hands save time. So they had a hardware team that managed the embedded development. So I'm going to review the hardware here. They brought us in to really help with the cloud infrastructure. So we're going to look at the app architecture right after this. But just so you understand how the data was getting to the cloud, let's take a look at the hardware. So first, we've got the ear tag. Ear tag was attached directly to the pig. It had an accelerometer in it, and that accelerometer tracked their movement so that they could tell if they were sitting, standing, laying down, all of the above. It would also collect the beacon information, which is the middle there. So the beacons were placed in the feeding troughs and in the water reservoirs, and they would emit a signal, and the ear tags would measure that RSSI, and if it got close enough, it would then collect the beacon information and send it up to the Raspberry Pi, which is the third item there on the right. That was just hung in the rafters of the barns, connected with the ear tags via Bluetooth, and then acted as a bridge up to the cloud. So now that you understand how the data was getting there, let's look at what we did once it was in the cloud. So as mentioned, got the pig here representing the ear tags connecting to the Raspberry Pi with Bluetooth. The Raspberry Pi was then transmitting the data into the cloud using an MQTT bridge. So initially that was with RabbitMQ and a custom-built IoT adapter that Augusto developed. Nowadays, that's replaced with IoT Core. So once the event data is landed in PubSub, or in the cloud, excuse me, we throw it into a PubSub topic, which can then be consumed by GKE, Kubernetes engine, in this case. Kubernetes then did some data transformation and wrote it to BigQuery for some additional analytics and their data team to be able to pull out into some visualization tools and build their data models. You also see Dataflow up there. That was just a simple backup storage. In case there was any errors writing it to BigQuery, we stored the raw event data in Dataflow. So The last thing here that I want to touch on is just the power of Kubernetes. I'm sure you guys have heard about it all next, but once we got this up and running, we really found out quickly that one pod was not going to be enough to handle hundreds of devices coming in per second from all of the pigs in the barn. So we were able to make a quick config update, scale it up to 3 pods. That was just for one deployment to be able to spread out the workload across all those pods. So ultimately, this is kind of what their visualization started to look like. They pulled it out, and we're able to tell when they were sitting and both when they were drinking, amongst a wide breadth of other data models that they were able to successfully build around reproductive and like if they're nesting, if they're ready to give birth, things like that. So in just over 2 weeks, they were able to get up and running successfully from the barn all the way to the cloud in order to build their data models. So it's pretty quick, and we were able to do it leveraging those cloud-native services. So that's just one example of IoT. We're going to look at another one here. It's a little bit different than monitoring pigs. So this is a manufacturing and technology company. And this manufacturing and technology company, they have a series of devices that help organizations of all shapes and sizes manage and monitor their inventory. One example is actually the badge. They have some printers, so they help print the badges on your next certificate or your next badge this week. So in order to help them manage that inventory, they wanted a scalable IT solution. Again, they had the manufacturing down and their own development teams that were managing the firmware on this hardware, but they needed something scalable and in the cloud. So here we come with GCP. Over just 3 weeks, we were able to get this architecture up and running. It was an initial POC in which, once we were actually wrapped with this, they selected GCP as their cloud provider of choice because we were able to prove out that it can scale rapidly and to the size that they need. So again, very similar to the pigs here. We've got the device on the left-hand side communicating with IoT core via an MQTT bridge. From that MQTT bridge, we land it in PubSub. Instead of GKE here, we have it being consumed by a cloud function. So it's just another compute option. I'm sure you guys have heard cloud functions. And then landing it in BigQuery for a data warehouse. After they selected GCP, we added some additional functionality. So this isn't within the 3 weeks, this extra functionality. But you can see it's kind of a daisy chained PubSub cloud functions. And what it's essentially doing is doing a lookup into Firestore, which is where they're storing some additional ancillary data. And if there was a filter related to that event that came in, they would land it in the cloud function, apply those filters. If the filters were passed, then he'd throw it in another PubSub queue to then eventually notify this webhook. And the webhooks were dynamic, so it could be an infinite number of webhooks. One example our customer used to demonstrate to their customers was changing a Philips Hue light bulb color, so from red to green to blue to you name it. So it's 2 examples here of 2 different IoT architectures. Pretty different use cases. So you might be wondering, like, how does this help you? And if you don't have an IoT architecture, it might not directly. But when you start to strip away some of the specific tools that are being used, and you genericize this app architecture, you can start to see some of the trends that we're talking about here. So moving forward here, back to the Internet of Swine, you've got IoT Core and you've got PubSub. So IoT Core and PubSub are acting as your ingest and event queue. From there, you've got it landing in a compute. And then BigQuery is for analytics. Data store is your backup storage. If we compare this to the inventory and operations, you've got IoT Core and PubSub. They're acting as your ingest and event queue. Cloud Functions is your compute, and BigQuery is your analytics. Looks pretty similar. So when you start to map that out, you can kind of draw a generic diagram of this nature, right? So you've got your IoT devices, whether it's a light bulb, a speaker, a tablet, a gateway device, communicating to the cloud. Could be MQTT, could be HTTP, all of the above work. Lands in typically IoT Core to then be consumed by PubSub. Once it's in PubSub, it can be consumed by any of those compute options: Cloud Functions, App Engine, Compute Engine, Kubernetes. And then land it in storage and both analytics. Usually for analytics, we're seeing BigQuery. It's a very powerful tool. A lot of customers want to get their hands on it. So, moving on to our next set of projects. This is analytics and ETL style projects. So we're going to talk a little bit about some of the trends we're seeing among those. So this first ETL customer, they come to us as a Fortune 500 retailer. They have their online shopping model, like all Fortune 500 retailers do. They have an option to ship from store. So their customers, when they're checking out, they can ship from store. And when they're shipping from store, they can get it at an expedited rate. But the tough part for our customer, they didn't have a way of tracking whether that order remained profitable for them. So they came to us with the ask of helping them define how can we determine if these ship from store orders are profitable. So this one's a little bit longer. You can say it was 3 months instead of in the weeks range that some of the IoT projects were. It's actually because our data scientist, he took a data dump of all of their orders for like a year or two, used Data Lab to essentially analyze all the data and build an algorithm to help determine if it was profitable. So once we were able to propose that to the client approved it, and we were able to get moving on the actual architecture itself. So let's take a look at what that architecture looked like. So as I mentioned, you've got the online ordering system. So as soon as the customer placed an order, they landed it on a Kafka server. From there, we used a PubSub connector to land it in PubSub. And the reason that we didn't bring it straight to Dataflow, under certain environments, you certainly could do that. This specific customer had a firewall that we just couldn't bypass. So we landed it in PubSub with the connector as a way to get it into Dataflow. So from there, PubSub consumed the messages off the topic, ran its ETL job. In this case, the algorithm that our data scientists had created in the initial phase. And then we landed it in BigQuery for their analytics team, and their business users then consumed it via Tableau. So after about 3 months, this retailer went from not being able to determine whether or not an item was profitable to being able to turn off the ship from store item option on their online shopping store for those items. Next company here for ETL, we're going to talk a little bit about. It's a medical device company. They're located in Minneapolis, Minnesota. They have a companion app that they've published for their medical device, helps the users configure and monitor the activity on their device. And so they actually built this with Firebase to get it up and running quickly. They use Firestore and cloud storage on the back end. And as their research and development team started to see the data coming in from the users, all the usage data, diagnostics, they realized that there was a big opportunity for them to improve their users' experience by looking at that data. What they ended up doing was coming to us because in the medical industry, there's HIPAA, and your R&D team can't just get their hands on all that PHI, right? That's not good. So they came to us to build them a sanitized pipeline that their R&D team could then build models off to improve their firmware on these devices. So after doing a review of their app architecture, as I mentioned, Firestore and cloud storage really helped us move this along. 4 weeks. Architecture looked a little bit something like that. Again, you got your medical device. The app then wrote to Firestore. So as soon as it wrote to Firestore document, we put an on-write cloud function trigger on that data element type in Firestore. So if that changed, whether it was a create, an update, a delete event, really anything, it would then trigger this cloud function, do a lookup into cloud storage to find any related data, and then if you found that related data, it would land a message on PubSub. From here, it's all the same, right? So it lands into Dataflow, consumes that message from PubSub, performs its ETL, in this case, removing all PHI and anonymizing the data, and then landing it in BigQuery for their analytics team to do with what they will. Again, as we look at these two ETL projects, hopefully you can start to see some of the trends that you saw with the IoT projects. With the online ordering system, Kafka, it acted as the event trigger. This is a streaming job, right? So an event trigger that then landed in PubSub for the message queue, that then landed in Dataflow for ETL, and finally BigQuery for analytics. The research and data models. At Firestore and the Cloud Function that acted as the event trigger. From there, everything's the same again. Message queue is PubSub. Dataflow is your ETL tool. BigQuery is for analytics. So again, that might look a little something like this. You have your event trigger, whatever that might be. Could be a Cloud Function, could be the Kafka server, could be anything, really. Then you land it in PubSub. That's your messaging queue. From there, you got your ETL pipeline and analytics. Obviously, there's some other additional analytic options for analytics. But as I mentioned earlier, BigQuery seems to be the tool of choice amongst our customers. So one quick note up here, you'll see I also put all the compute options under ETL pipeline. If you think back to our IoT projects, both of those were also doing ETL with Cloud Functions and Kube, right? So you can roll your own. Dataflow is a great tool if it fits your use case, for one, and two, if you're trying to get stood up quickly. But you always have the option to roll your own, and the GCP compute services are a great option for that. So, all right, that's a lot of architecture. I went through that kind of fast. What is this? Well, what's the point of it all, right? So what we're trying to say is there's a lot of ways to accomplish what you're trying to do, and everyone has a unique problem. You all have your own industry, your own company, you're facing your unique issues, and we don't want you to walk away thinking that these are the only ways to solve the problem, because there's an infinite number of ways that you can go home and solve your issues. Well, what we're trying to say is that a unique problem doesn't need to equal a unique solution. You saw two examples of two different companies that had very different use cases, but they benefited from the same underlying architecture. So reference architectures are your friend. There's no shame in using it. It is tried and tested. And quite frankly, there's no extra credit for originality. So you can save both your organization time and money. All right, so switching gears a little bit. You might get home from Next. Be ready to start down this journey, new project. Come across a list that looks a little something like this, and then close your laptop because you're a little bit overwhelmed. So to help curb that overwhelming feeling, pass it off to Ray over here. He's going to talk about some of these services that we see most frequently.
Thank you. Hey everyone, I'm Ray. So that's a big list. 50 plus platform services, APIs. I think I got about 10 minutes, so we're going to go into a deep dive, all 50 of them. Don't worry, I'll talk fast. You guys ready? I'm just kidding. But we are going to discuss a few of the favorites that I have and stuff we use for prototyping. First thing I'm going to start with is IoT Core. It's Google's managed IoT platform. Why do I like IoT Core? Well, it's serverless. So a few slides back, Patrick showed the IoT adapter that we made and RabbitMQ. That all ran on a virtual machine. Required patching, management, configuration. Plus, building a Rabbit cluster that can handle 1 million connected devices is not trivial. So IoT Core will just scale up as you can connect as many devices as you want to it. So let's talk about some of the features of IoT Core. So with IoT Core, it supports device state configuration and authentication. For communication with IoT Core, you can use MQTT and HTTP. We all know about HTTP. Let's talk about MQTT for a minute. So MQTT is a light rate messaging protocol, runs on TCP. One of the differences between HTTP and MQTT is that MQTT device will typically make a connection and hold it open to the server. So HTTP, usually a device will connect, send a bunch of headers, negotiate encryption, and then disconnect. With MQTT, it holds connection open for as long as it can. Could be hours. By doing so, you don't have all that overhead, so it uses a lot less data, especially when you're talking about a device that maybe you're paying for cell data on. So, and plus, when you have a device connected via MQTT, you can push config to it. So the device is already subscribed to configuration or command topics, and so what you do is you use an API call into IoT Core, and it'll push config directly to the device. You don't have to wait for that device to make it a request to pull data. So, and IoT Core is really, its core purpose is a protocol bridge. So when you connect to IoT Core, device sends data, it really ends up in PubSub. So PubSub, it's a managed real-time messaging service for GCP. So, and IoT Core device sends data and ends up in PubSub, and it's consumed by your application. Your application is a subscriber in PubSub. So, as I said, messages are published. So you publish to a topic in PubSub, and again, it doesn't have to be just IoT Core, but you can use PubSub for sending messages from machine to machine. So you'd be a publisher, publish to a topic, and then you'd have subscribers. So you have multiple applications that could subscribe to the same topic. So you can fan out the data, send it to multiple places. There are other uses of PubSub. So we use PubSub commonly to distribute work. So in one of the other examples that Patrick had, he showed cloud functions, daisy chaining via PubSub. So you could have one cloud function, has a lot of work to do. What it can do is it can publish that to a PubSub topic. You can have many cloud functions subscribed, all doing the same thing. So you end up scaling horizontally without doing a lot of work. So some of the features of PubSub, important to PubSub is it's a durable message queue. So if a message makes it into PubSub, it's going to stay there until you pull it out, or I think 7 days, they'll eventually throw it away. It has fan in, fan out support. So as you can see, you can have multiple publishers publishing the same topic. You can have multiple subscribers of the same topic. It's easy to integrate. There are client libraries for just about every language. It's very performant. And as I said, it's guaranteed delivery. So when a message is published into, when a message is pushed into PubSub, it's waiting for a subscriber. A subscriber pulls that message. It has to acknowledge that it got the message. Otherwise, PubSub will put it back in the queue and wait for someone else to grab it. There are a few caveats to using PubSub. The message order isn't guaranteed. So if order is important, you'll have to sort that out in your subscriber side. PubSub supports at least once delivery. What that means is that it's guaranteed to deliver it at least once, but it could deliver it more than once. So you could get duplicates. You're also limited to 10,000 topics and 10,000 subscriptions per GCP project. So because of that, that's one reason you wouldn't have like an end device published directly to PubSub. You have more than 10,000 devices, publishing 10,000 topics, you don't do that. So that's what you use IoT Core for. Next thing I'm going to talk about is Cloud Functions. So we've been using Cloud Functions a lot. Cloud Functions, obviously they're serverless, easy to deploy. You can trigger Cloud Functions a couple different ways. So via an HTTP request. So think about just a typical web service. Make a request in. You can also trigger a Cloud Function from a file dropped in Cloud Storage. So we'll have an ETL pipeline that might have a Cloud Function watching a Cloud Storage bucket. A file shows up, it's automatically triggered. It knows about the file in that Cloud Storage bucket. It can grab it and do some stuff with it. You can also trigger it from PubSub, right? So one Cloud Function can subscribe to a PubSub topic. You can also monitor a Firestore database. So it can be triggered from that. So data changes in the Firestore database, and a Cloud Function can be activated as well. So in our prototypes, we're using Cloud Functions for, as the example he showed, calling webhooks. So Cloud Function spins up, hits some other service in some other cloud provider or wherever. Cloud Functions can easily read and write data to Firestore database, Cloud SQL, BigQuery. And of course, you can send data out, PubSub. You can publish from Cloud Function to an external service or obviously another Cloud Function. And you can see from the previous examples that we use Cloud Functions all over the place. Next, I'm going to talk about BigQuery. So BigQuery, I love BigQuery. BigQuery is awesome. If you haven't used BigQuery, you should use BigQuery. So one point I like to make about BigQuery, you don't need to have big data to use BigQuery. So you can have just a little data in BigQuery. So it's great because if you know who wants to spin up a SQL server, if you have a task you want to complete, you need some place to store some data and query it later, BigQuery will work. You could have 100 rows. To set up BigQuery, you go into the UI or you can do it via command line or API. You create a data set, then you load data into tables. That's it. And like many of the GCP services, you pay for what you use. So for BigQuery, you pay to query the data. You get a lot of. There's a lot of. You'll see later. There's a free tier for that, but it's really relatively inexpensive, especially with small data sets. And then you pay a tiny bit for data storage. We're talking pennies per gig. And there's very little configuration for BigQuery. So you want to make a table, you define the table schema, and then you create a table and you load data into it. So a couple of ways to load data into BigQuery. You can stream the data in. So BigQuery supports streaming you can stream up to 100,000 rows per second into BigQuery. Obviously, it's very performant. You can also load via batch job. So think about taking like a JSON file or a CSV file, put it in the cloud storage, point BigQuery at it. It'll ingest it and put it in a table for you. You query your data out of BigQuery using standard SQL. You can use common BI tools. An example we had was Tableau, but it works. If you've walked through here, you've probably seen 20 different tools that you can query your data with. Looker, Data Studio. You can connect. You can do Cloud Data Lab. Connects directly to BigQuery. So data scientists, data engineers spin up an IPython notebook is what Cloud Data Lab is, and that'll connect directly to BigQuery as well. So one thing you wouldn't use BigQuery for is to store your data if you're going to try and drive a website, like a real-time dashboard. So one thing you'll learn when you do a query, it's going to take a couple seconds. It doesn't matter if you have 20 rows or 20,000 rows. It's a couple seconds to query that data. So you wouldn't want to wait to populate a web page with data in BigQuery. You'd want to run a query and bring back like a report. So where would I store my data if we wanted to have it available on a web page? So we use Cloud Firestore a lot. Works well with Cloud Functions. It's all integrated. It's a document database, so you're storing key value pairs, NoSQL. So we'll commonly use that to store configuration, application state, stuff like that. So it supports real-time updating too. So a web developer can create a dashboard, and with very little effort, you can have it so that if a value updates in Firestore, it just automatically updates in your dashboard. So you're looking at a web page, you don't have to do anything to pull data. It's automatically shows up updated value. So we'll use that when we're building dashboards showing application state or status or counters, things like that. We'll use Firestore for that. You can back up your Firestore data to cloud storage as well. So Google added support for that. From there, once you have your data, your Firestore database, you can back up the whole thing pretty much. You can restore it back into Firestore. So you're thinking you could use that for disaster recovery. So not necessarily that something crashed and you lost your data, but more like if somebody you overwrote your data or you deleted it, you wanted a copy to restore to, you can do that. You can also export that back up to BigQuery, and we've done that quite a few times. So if you have all this data in Firestore, you can't really point an analytics tool at Firestore. But you can obviously do it to BigQuery. So Google has made a feature of the Firestore backup is that you can restore that directly to BigQuery and do your analytics on it. And we've got customers that are doing that. So another thing we use a lot, cloud storage. Obviously, cloud storage is most people know about that. You can store anything in cloud storage as long as it's a file. So a couple of things about cloud storage that are interesting. So it's virtually unlimited, right? Store as much as you want in there. You just pay for what you use. Again, it's pennies per gigabyte. There is a 5 terabyte file size limit, though. So if you have a file bigger than 5 terabytes, you're going to have to cut it up. It's got 11 nines of durability, so you're not going to lose your files during cloud storage. And there are many tools for managing your data in cloud storage. So you can use their client libraries, command line tools, the cloud console. So when you get back home and you start spinning up your projects in the cloud console, you can upload and download files directly out of cloud storage using the web UI as well. There are multiple storage classes in cloud storage. So you may have heard of these regional buckets, multi-regional. So when you create a bucket, you decide what type of bucket you want, what you want your storage to be. So if you pick a multi-regional bucket, then you store data there. Google spreads that data out, stores it, bunch of pops all over the place. It puts the data closer to your users. So if you've got users downloading data, there'll be less latency there. You wouldn't necessarily want to do that if you're doing analytics workloads, though. So they also have a regional bucket. So you can imagine if you have a ton of data you need to process, you would maybe build your app to run and deploy it to like the US Central. Well, you can deploy your bucket, data from your bucket, also in US Central. So so you can download faster. And it costs a little less when you do regional as well. So they also have nearline, cold line. You've probably heard of those. That's for less frequently accessed data. We typically wouldn't use that for prototype. You're usually storing that for backup. So talk a minute about Cloud SQL. I like Cloud SQL. It's not as easy to set up as BigQuery, but it's certainly simple enough. So we don't use it as much for prototyping because it's more configuration. It's still a great option to store your data. Currently, Cloud SQL supports MySQL and Postgres. You can have a SQL server running in 5 clicks in the console. You can go into the GCP Cloud Console. 5 clicks later, you've got a SQL server running. Supports all the stuff you'd expect from a database service: high availability, failover, automated backups, point-in-time recovery, auto storage increase. So you can have up to 10 terabytes of storage. You can connect to it just like any other SQL. So if you've got an app that needs to communicate with a MySQL or Postgres server, you connect to it the same way if it's running in Cloud SQL, or if it's running on a virtual machine, or if it's running in your data center. So another thing that we've been using a lot is Cloud Dataflow. So Cloud Dataflow is a fully managed service. It supports stream and batch processing. So one of the ideas with Cloud Dataflow is that if you write your app correctly in Cloud Dataflow, you can use the same logic whether it's streaming data in or you're doing batch. So it's serverless, it's auto-scaling. So the idea with Cloud Dataflow is you submit a job, it'll spin up as many nodes as it needs to. It'll work until the job's done, and then it'll spin them down. If you're doing streaming, it obviously won't do that. It'll keep your streaming job running forever, or until you kill it. So common pattern for Cloud Dataflow is to write data out to BigQuery. So we showed that previously. So you can also write data out to Cloud Storage or PubSub. And with the example that we had earlier, we were using Dataflow to do data redaction, data enrichment. So in that example, Dataflow was reading data out of a BigQuery table. It was reading flat files out of Cloud Storage, combining that data, and then redacting it and pushing it back into a different BigQuery table. And then from there, the guys could do their analytics on that clean data. So Firebase hosting is another thing we use. That's pretty straightforward. All it is static files. So we're building a dashboard or there's some web component to our prototype we're building for somebody, you can stick your HTML, JavaScript, CSS, all that stuff can go in. A Firebase hosting, it's really easy to do. It supports custom domains, all that stuff. Another thing we're using is Firebase Authentication. So authentication isn't easy. Firebase Authentication makes it a little easier. So it's quick and easy to set up anyway, and it's a secure way to add auth to your app. So when you're doing a prototype, a lot of times you don't want to spend a ton of time building roles and permissions and all the authentication that you would have in a full-blown app. Firebase makes it a lot easier to do that. In our case, instead of doing, so you can, with Firebase, you can do, there's, I don't know how many different ways to do authentication, it's social and all this stuff. What we usually do for a prototype is we'll just enable username password. So it's email password, actually. So you can go into the console and put emails and passwords in, and Firebase takes care of that. So they're hashing it and encrypting it and storing it. Then we use APIs to authenticate a web app with that. And in a lot of cases, we'll give that Firebase console, since we're building these for our customers, we'll give that project to the customer, and the customer can log into the console and add their own users to it. So they've got a UI built in to do that right in Firebase. So back to the list. I obviously didn't go through all 50 of them. I just scratched the surface. I didn't get in a ton of detail. There's so much we could spend a whole week talking about this stuff, right? So, but we will use a lot of these other services as well, obviously, if it makes sense. There are a lot of different ways to do the same thing, and for prototypes, we try and find the most efficient, quickest way to do it, simplest way to do it, so we're not spending a lot of time and a lot of money. It's a big list. So if you guys want to geek out about any of these things later, we can stop by our booth. I'll be glad to talk to you about it as much as you want. So with that, I'm going to hand it back over to Patrick. Let him talk for a little bit.
Cool. Thanks, Ray. All right. Before I move on to this next slide here, one more question for you guys. Who likes free stuff? If you don't know about GCP's free tier, you should. It's literally free, hence free tier. It's really helpful when you're testing out a new technology. You don't have to spend your own funds on it. It's a good way to play around with some of their new services that they've announced here today. If you land on cloud.google.com/free, it'll show you a list of services. When I was throwing this presentation together, that was the list. I can't promise that is still the same list. Google reserves the right to change that. But you can go there. It'll show you all the details of what their free tier is and some of the caveats. But a lot of the services Ray just touched on that we use in our prototypes every day are on that list right now, right? So you have Cloud Firestore, you have Cloud Storage, PubSub, Cloud Functions, GKE, BigQuery. So you can get a lot of value from the free tier if you're leveraging it. So a couple of free tier examples that I like to touch on that I really find a lot of worth or value in. Cloud Functions, one of them. You get 2 million invocations a month. It's a lot. There are limitations on compute time and some network egress, but 2 million invocations is still nothing to scoff at. The other one would be BigQuery. Obviously, we have a little bit of a crush on BigQuery, but you can run a terabyte of queries a month. That's nothing to scoff at either. 10 gigabyte storage limit, still quite a bit of data that you can query. So what's the point in all of this? Leverage your free tiers and leverage the cloud native services. All the services that Ray went over and that free tier that I was just discussing, they're meant to make your life easier, help you save money and resource hours, something that I'm sure all of you could appreciate in your day-to-days. And also it helps you focus on some more strategic initiatives. If you're able to save that time, you can start focusing on some more innovative thoughts that you and your team might have. So that's a lot better than just focusing on keeping the lights on. All right, last thing for today, do's and don'ts. So we're consultants, obviously, right? We work with a lot of organizations, and we get to see both the good, the bad, and the ugly. So some of these do's and don'ts are going to seem like complete no-brainers. I wish they were. They're not always. So if it is a no-brainer for you, that's good. That means you're doing it right. But just some things to keep in mind. So the first start with an idea and formulate a plan. Simple, right? Of course. But it's really easy to get excited about your idea and just jump straight into it. But if you're doing that, you're probably not going to end up very successful. You're going to waste time. You're going to waste budget hours. No one wants that. So slow down a bit, define your approach, figure out your key use case requirements, and then take action. That said, don't overcomplicate your approach. It's a POC or it's a prototype. It doesn't need to be complicated. So just define it at a high level. Define what is going to look like success. So speaking of success, define your success criteria. If you don't define your success criteria, how are you going to brag about being successful? To your boss, to your colleagues, anybody. It also helps the rest of your team stay focused on the end goal. If you don't have that success criteria, how do they know what they should be focusing on? So, one important thing around that success criteria, it's not just functional. There's non-functional requirements as well. Do you have performance requirements? Do you have security requirements? Those are things that you should be considering in these prototypes. But don't confuse a POC or your prototype with an MVP. So prototypes kind of land in between POCs and MVPs as far as I'm concerned. Your MVP is meant to be a market viable product, right? So minimum viable product, but it's market ready. POCs, generally internal facing, you're trying to determine feasibility of it, maybe test a new technology, prove something out, right? So if their success criteria are identical, you should probably take a step back, think about why they're identical, and figure out which one you actually need to do. If you're not proving out a new concept, a new technology, maybe you don't need to start with a POC. So either way, having the right success criteria is key for the last one. I've already alluded to this. Set expectations with your key stakeholders. There's nothing worse than getting to the end of a project, presenting what you have, you're excited, you think it was a smashing success, and then your stakeholders have this blank look on their face. They're confused, they're wondering where the features they asked for were, and it's because you didn't set their expectations properly, or at least most likely. So if you can talk with them early and often, set those expectations on what you're going to deliver, when you're going to deliver it, that's going to help you in the long run to get the reactions that you want at the end. The other side of that coin, don't be afraid of changing course or strategy. And I've seen it a couple times where a product owner doesn't want to change their course because they've already reported to the stakeholders, this is how we're going to do it, and we're not going to do it any other way. But they get down that path, they realize it's not a viable strategy, and they still continue down that path. You're wasting time and money. That's not good for you, it's not good for your company. What you really should be doing at that point is pausing, reassessing your other options, resetting expectations with your stakeholders, and changing your course. The whole point of a POC or a prototype is to determine feasibility, right? So if you find out that it's not feasible, there's no point in continuing down that path. That leads to the last point of the day. Have a plan, communicate it, and take action. The last one is key as well. Take action. A lot of projects fail because they haven't started. So don't forget that last one. All right, so this is about wrapping it up for us. Just a couple of key points. We've already touched on these, but if you learn nothing else from us today, hopefully these can stick in your head. Number one, unique problems. They don't have to be unique solutions. Use reference architectures. They're your friend. Leverage the free tiers and cloud-native services. They help you save money and time. And then have a plan, communicate that criteria, and take action.